We will take a practical scenario to understand why we need a finite automata or we need a automatas. Consider a C program. We know that A, comma B up to Z in small letters, also in capital letters, 0, comma 1 up to 9 numbers, plus minus multiplication division are the arithmetic operators. All are considered as the alphabets in TOC. Okay, so the same alphabets are available in the program also. Okay, so in this, let's take this is a valid C program and this program is for addition. In C programming it is called as a C program, but in TOC we will considering it as a set of strings. It is nothing but a set of strings. And we know that C is the programming language which contains lots of programs. So we can say that in C we have a huge number of valid programs. Suppose we can also say that it contains the infinite number of valid programs like P1, P2, P3 up to Pn. And we have given a problem like Px and we have to identify whether the Px is a valid program or not. In this, we have the list of valid programs that is present in the set P1, P2, P3 up to Pn. These are the valid programs. We have given a Px program and just we have to check whether that Px is valid or not. If that program is valid, then it is definitely found in that particular set. If that set is finite, then we can easily identify the valid it is valid or not. But consider if that is a infinite in number, then if that is the last program valid program, but that is an infinite series, then how much time we required? Okay, so it will go in an infinite loop. Okay, so we will not able to find the answer in a polynomial time. Likewise, for the languages also, we can say that if consider one example is there, language is finite. We are taking the language is finite over the alphabet A comma B. Language is set of all the strings of length 2 over the alphabet A comma B. And we know that AB, BA and BB, these are the 4 strings present in the language over the alphabet A comma B of length exactly 2. And we have given a one string, we have to check whether this string is present in the language or not. Then what we will do, we will check this string with every other string present in the language, and if it will match, then we can say that the string is present in the language. But if it will not match, then we will definitely say that the string is not present in the language, and we can clearly check that string is not present in the language, and that we can do in a polynomial time. But if the language is infinite, suppose the language is like this, starting with A over the alphabet A comma B, means it will contain all the strings starting with A over the alphabet A comma B. So minimum length string is A, then A, AB, ABA, ABB, ABAB, okay. It will contain all those strings which are starting with the letter A. And we have given that the string BABA and asked for check whether this particular string is present in the language or not. Okay, logically we can say that this is a string which is not present in the language, but machine will not think logically. It will check with every other string if it will match or not. And in the language we know that there is an infinite number of strings, so it is very difficult to check the string yes with every other string in the language. It will go into the infinite loop. Okay, so this is the problem. That's why we need a some machine so that it will give the answer to us in a finite time. Okay, so for that purpose we are going to check whether any option is present or not. तो यहाँ तक हमने क्या देखा कि अगर स्ट्रिंग जैसे कि अगर लैंग्वेज फाइनाइट होगी then we can easily say that the particular string is present in the language or not. But अगर language infinite होगी then it will be very difficult to check whether the given string is present in the language or not. So we need some solution such that given a language we can come up with a finite representation. मतलब अगर लैंग्वेज गिवन है तो उसके लिए हमें फाइनाइट रिप्रेजेंटेशन चाहिए. जैसे कि अगर मैं कोई स्ट्रिंग पास करता हूँ if that string is present in that language then it directly says that okay this string is present in the language. But if the string is not present in the language, the machine in a mode to say that the string is not present in the language. So here we can say that suppose language L is there and we need some finite representation, or we can say that finite automata, such that if I will give any string to that finite automata, it will say yes if that particular string is present in the language, or it will in a position to say no if that particular string is not present in the language. Suppose there is a language L1 which says that set of all the strings which starts with A over the alphabet A comma B. So language contains the strings like starts with A means starting with A and ending with anything. So string contains like A, triple A, ABA, AB. So infinite number of strings will be present in this particular language. So we have designed a finite automata for that particular language. Okay, अभी आपको ये समझ में नहीं आएगा लेकिन just we have to design such type of finite automata so it will be able to answer whether the particular string is present in the language or not. Like here this arrow denotes it is a starting state. ओके, सो यहाँ पे अगर मैं ए पास करता हूँ तो मुझे क्या करना है एक्सेप्ट करना है. सो मिनिमम लेंथ स्ट्रिंग ए शुड बी एक्सेप्टेड. सो डबल सर्कल जहाँ पे होता है दैट इज कॉल्ड एज द एक्सेप्टेंस स्टेट और ए फाइनल स्टेट. हमें क्या चाहिए ओनली स्टार्टिंग विथ ए एंडिंग विथ एनीथिंग. मतलब अगर ए आ गया तो उसके बाद कुछ भी आए तो वी विल गोइंग टू एक्सेप्ट इट. सो इसके बाद अगर ए कॉमा बी कुछ भी आता है तो आई एम एक्सेप्टिंग. बट अगर इनिशियल स्टेट से ही स्टार्टिंग विथ बी अगर स्ट्रिंग आती है तो मुझे ये एक्सेप्ट करनी है क्या? नहीं. सो अगर स्टार्टिंग विथ बी होता है तो मैं सी स्टेट पे जाऊंगा और उसके बाद ए कॉमा बी कुछ भी आए तो मैं क्या करूंगा उसे एक्सेप्ट नहीं करूंगा. मीन्स वी हैव टू रिजेक्ट दैट. ओके, तो एक्सेप्टेंस कब बोलेंगे और रिजेक्शन कब बोलेंगे? Okay, let's see. Suppose one string is given like AAB. So initially I am in A state, and after seeing the first alphabet in the string, A is there. So A on small a, I am going to B. Again, I will check next A. Then for next A, I am staying in B only. For next B, I am staying in capital B only. Okay, so when we can call it as a string is accepted? When we will starting from this initial state, and after scanning, we are scanning the alphabet. After scanning the string, after scanning the string, if we are present in the final state then we can say that the string is accepted. Now we can clearly say that this is the final state, and after scanning the string we are ending in a final state, so we can say that this string is accepted by this finite automata. Likewise, we will check another string. Initially, I am in A state, and after seeing an input alphabet, that is B, I will go to the C state, and after C, when I am in C, if I will see the input alphabet A, I will present in the C itself. So here we can say that after scanning the entire string, we are not able to finish in the final state. So we can say that this string is not present in the language because we are not ending in a final state. ओके, आई होप आपको यहाँ तक समझ में आ गया होगा. Now in next lecture we are going to clearly focus on finite automata.